WebAssembly's developer experience, of course, is really just trying to narrow in on the developer doing what the developer does best. I know what my code should do. I know what libraries I want to use in order to do it. Everything else is operational, and I don't really care what kernel version, what operating system, what architecture. That's an operational concern.
Today marks the launch of Fermyon Cloud. Can you tell us what is Fermyon Cloud?
Fermyon Cloud is where we're trying to build the simplest way to run WebAssembly microservices in the cloud. So with Fermyon Cloud, what we really want is to go from blinky cursor to your app is now deployed and highly available and can scale in the cloud in less than 2 minutes. And I'm very keen on the less than 2 minute part.
Fermyon Cloud is a hosted platform where you can deploy your Spin applications. And as you deploy them there, you'll have instantly your TLS will be all configured. You'll have a dashboard for managing your application. You'll be able to look at the logs. It'll be publicly available so you can share it with other people. In essence, we're trying to accomplish for WebAssembly that same kind of ease of deployment and developer self-service that we had, in Heroku and Vercel and other places like that. But drawing all the benefits of WebAssembly into this. So you have, the ultra fast startup times, you have the language neutrality where you can pick the language that you love the most and build your application in that. And then we really have worked hard to make the developer experience better and better for this application. We've learned a lot from the way PaaS systems in the past have worked, contemporary JavaScript deployment platforms have worked, and we want to roll those lessons in. Ideally, so that you, as the developer, can really start working with Fermyon Cloud as part of your development, what we call the inner loop, right? As you're still hacking on things and you want to just test a deployment out there, see if it's working, it should be super easy and trivial for you to do without taking minutes and minutes for something to spin up. It should be nearly instantaneous. And that's really been the guiding principle behind what we wanted to build with Fermyon Cloud. I'm Matt Butcher, online pretty much everywhere. I'm Technosophos. I come from an unlikely background. My formal education is actually in philosophy. I have a PhD in philosophy, but programming has for a long time been my passion. And just about a year ago, in November 1st of 2021, we started Fermyon, and I'm the CEO.
Hey, I'm Radu. I'm one of the co-founders of Fermyon. And I'm almost always around computers. So when I'm not, I'm usually either listening or playing classical music, cycling, or bubble tea. Those are pretty much the only things I do outside of computers. So yeah, nice to meet you all.
Can you give us a bit of history, flavor, and context around the name Fermyon, please?
There are two fundamental particles in the known universe. There are bosons and there are fermions. And fermions are the ones responsible for most of the visible matter in the known universe. One really cool property of fermions is that they observe the Pauli exclusion principle, which essentially states that no two fermions can occupy the same quantum state. And spin, on the other hand, is a fundamental property of all particles, and in particular, there's a nice correlation between the spin of a fermion and how it behaves. So, high school me was very into particle physics and was very excited about that. And when it came to naming something as huge as a company, I suggested Fermyon, and the analogy started pouring very easily between particle physics and how they behave and how fermions behave in particular, and what we were trying to do with microservices and really lightweight computing entities that we can scale, and no two of them can occupy the same state at the same time. And there were a bunch of analogies that we can make from all of that. So that's in a nutshell where the term Fermyon and the name of the company and what we're doing with computing where they overlap.
But I'd like to go back to your time before WebAssembly and Fermyon and understand that transition more. Like I want to understand if you can remember the moment where you were like, oh, WebAssembly. Like what was that moment that kind of piqued your interest? Why did you make this jump from container cloud native into the WebAssembly ecosystem?
So I think I can look back at all the projects that I've worked on before WebAssembly and before Fermyon as in one of three buckets, either developer experience, distributed systems, or security tooling. And what fascinated me about WebAssembly very early on was it's right at the intersection of those three, and it gives you significant improvements in some of those three areas, if not more of them or all of them. So the immediate thing that piqued my interest was being able to take the same compiled artifact, the same compiled bytes, and run those across operating systems and CPU architectures. That was the first thing that was coming from the world of containers, where you had a container image and that was bound to an architecture, to a CPU architecture and an operating system. And you needed to have something like multi-arch images to get the same application to run in multiple environments. The fact that you can take the same WebAssembly module and run that in Linux on ARM, and then Windows on AMD, and then somewhere in the cloud that you don't really care about what the architecture is, was fascinating. And then you get stuff on top of it, like, oh, this actually starts in less than a millisecond, and it runs in an isolation sandbox. And the more I read about WebAssembly, the more, and this is still early 2018-ish, something like that time frame, the more I read about it, the more I was fascinated with the technology itself and with the ecosystem around it.
One of the coolest things about being at Microsoft Azure in the time we were there and on the team we were on was that we got to talk to customers, we got to talk to other internal Microsoft Azure teams, we got to talk to the people building .NET and the people building HoloLens, right? All these different teams. We talked to small, medium, and large customers. And, our mandate there was really to solve problems with containers and see where we could push the boundaries. But there were always things that we didn't seem to be able to do terribly well with containers. We spent a lot of time and energy trying to solve cross-platform, cross-architecture things, trying to figure out how to scale things down to the absolute bare minimum, ideally 0, right? Because it's expensive to leave things running when they're sitting idly. So can you get them all the way down to 0? And then if load comes in, can you scale them all the way up to whatever the load demands, 10,000 or whatever? And we had this whole list of things that we really wanted to be able to do, and we had tried it various ways, and nothing was really sort of feeling satisfactory. The team, the Deus Labs team, was kind of hanging out together after our semi-annual planning, and we had finished dinner and we were just kind of hanging out at a restaurant, and we got to talking about what potential ways were to solve this, and also moving on from there, what were the next things we wanted to be able to do with computing, being able to dynamically swap in and out dependencies of things, being able to dynamically patch. If OpenSSL goes bad, you shouldn't have to rebuild tens of thousands of container images just to patch the OpenSSL thing. And that, at scale, at a place like Azure, that's a very real concern, right? There should be some way to hot patch these kinds of things. Maybe WebAssembly would offer it. So there were all these things that are sort of flying fast and loose in this conversation. And we got really excited about the potential of WebAssembly as a runtime because of many of these kinds of things that were good for the browser. And so we began experimenting with WebAssembly to see what kinds of things we could build. We built all kinds of things with it, many of which thankfully never saw the light of day. We had a project called Walk, which was WebAssembly on Kubernetes. There was a very bad attempt to do this at a very, very low level inside of Kubernetes. We replaced that later with Crustlet, which is now a CNCF project, which was a much better way of doing things inside of Kubernetes. But there was just a lot of learning going on as we tried to figure out, how do we realize the potential we're seeing with WebAssembly? How do we really take this virtual machine technology, combine it with the cloud environment we need to be able to solve the problems we had identified, and then run with it? The initial experiments, some were successful, some were not. But as we went, we kept getting more and more excited that what we were seeing was some real potential. We have to adjust a little bit here. We have to think about microservices differently. We have to think about serverless a little bit differently. Have to think about threading a little bit differently. But as we did that, we kept seeing success, right? And we kept seeing, oh, this is indeed the experience we need to fill that gap we had identified as sort of like the next wave of cloud computing.
If you look at the history of computing over the last decade and a half, you look at the evolution from deploying physical servers to virtual machines and then to containers. And then with Kubernetes and container orchestrators in general, we've seen a bit of an evolution in the way we develop and deploy applications, which was significantly better and improved compared to VMs. So if we look at what's next, we can see something like WebAssembly being able to improve on the things that are still a pain point with containers. And that's why we look at this as, and we really think it's the next evolution of computing.
Again, when we first started exploring this realm of what comes after containers, what's the next complementary technology to containers, WebAssembly showed up as having a different set of characteristics, right? You pre-build a static binary or a binary with its supporting files, and you package all of that stuff up, but you don't need the file system because the file system is all virtualized, and you don't need the system utilities and libraries and things like that. All of that could be provided directly by the infrastructure. That's what Spin does for us, right? And that really feels like the next wave of cloud computing. And now the interesting thing is that as the waves accumulate, right, it's not that virtual machines got replaced by containers and WebAssembly will replace containers, right? Each time we make a sort of incremental step where it's additive, we're adding one more thing, but we're not subtracting anything else. So virtual machines are still a stronger market now than ever before, and the tooling for managing virtual machines continues to improve, and we're all still excited about them. Likewise with containers. And I think WebAssembly will be that next complementary technology that really where we can build more advanced, lower cost, and higher performing things by combining these three technologies.
I'm seeing more and more of environments where people run containers and WebAssembly side by side and doing that successfully. So if you go to finickywhiskers.com, that's a fun cat game where we have to feed a finicky cat that changes their mind on what we want to eat. And that's running in a hybrid architecture where we have like 8 WebAssembly microservices and some Redis instance there, and they're just running side by side in a Nomad cluster, and they happily coexist.
So these kind of hybrid applications where we can use containers and WebAssembly and virtual machines and whatever else comes along, those I think are always going to be more powerful than ecosystems that try and attain that sort of monolithic or homogeneous kind of stature where everything only is built in Java or everything only is executed inside of this particular kind of architecture or something like that. And so we kind of have a leg up in that we know right away that we can use containers right away with WebAssembly right now.
Tough question then. In 5 words, can you tell me what is the component model?
Yes, I think in 5 words, the component model would state that WebAssembly is the library. That's 4 words. No, that's 5 words. Crap, I can't count. Hold on, I need more fingers. WebAssembly is the library. And what I mean by that, WebAssembly is the library. That is 4 words. I'll go with WebAssembly binaries are the libraries. Radu will give you a better answer.
Describe WASI and the component model in under 30 seconds.
So if you think of WebAssembly as the specification itself, it describes a binary format, right? And it describes how things are supposed to be executed. The component model comes on top of that and describes how two modules can intercommunicate and share non-trivial data types between them. WASI comes on top of that even and describes how you would do I/O operations between those different components.
What I'm curious about here is that we're going to have people migrating from existing cloud native environments, Kubernetes environments that went through the last 5, maybe close to 8 years of microservice adoption, re-architecture, etc. How does WASM change how we think about building complex applications? Do we get to carry over and transfer all of that knowledge we've kind of either painfully learned over the last 8 years? Or do we have to learn something new completely?
I do have some very bad news for people. All of your YAML knowledge is not going to come in useful in the WebAssembly ecosystem. I don't think we have any YAML files. You're going to have to put away the ruler you used to measure the indentation on your screen. Yeah. Realistically, the general ideas behind the technologies we've been using in the last few years in the container ecosystem, all of those are going to carry over, right? To the extent that even we will continue to use containers. Remember, there's no zero-sum game here. WebAssembly is not defeating containers or rendering them irrelevant. It's just adding a new tool, and a tool that we believe is necessary in order to achieve what we really want to achieve. So we liked the serverless idea a lot. And by serverless, really, I'm leaning more toward the functions as a service style of definition where a developer can say, look, I'm going to write an HTTP request and response handler. I don't have to stand up an entire web server and set up the TLS configuration and manage the process and interrupts and things like that. I'm just going to write the handlers that I care about. And we heard repeatedly that developers really like that model. We ourselves really like that model. But it was not possible to really do with that model what we wanted, right? You ended up being locked into very specific platforms with very specific assumptions about what could be done. So on one hand, there was that piece that we really cared about. On the other hand, there's the performance piece that we really cared about. Think about the number of your standard Kubernetes application, for example. You start up an application, a deployment. You're running at least 3 copies of your microservice. Right? Even if you have barely enough traffic to keep one of them active, you're running 3 because you need the failover. And all 3 of those are consuming the same amount of resources on the 3 different nodes they're running on. Now, as you start scaling up, you might be running 5 or 7 or 15 or whatever. And those are there because during peak load time, they need to be there. But during downtime, they don't, right? At 2 a.m. in the morning, load is low and you don't need to be running all 3, 5, 7, however many of those. But we do because we don't have another way of doing it. Likewise, if we get pummeled by traffic, right? Something trends up on Hacker News or Reddit or something like that, and we get slammed with traffic, we don't have the ability to really, in the container ecosystem, to really scale up terribly quickly either. And so consequently, we have to plan ahead and we have to hope that we're lucky enough in our planning that it holds true. WebAssembly gives us a different alternative to that way of thinking, right? Because these modules are so small and because they use a sort of serverless programming model that is stateless, which is, of course, a virtue of microservices. All microservices should ideally be stateless and use a stateful service to store their information. And because of those features, then, you should be able to start and stop them as quickly as you can. Now, imagine instead of taking several minutes to start up a virtual machine or several seconds or a few dozen seconds to start up a container, you could instantly start up your application and instantly shut it down when it wasn't handling traffic anymore. That's the model we pursued with WebAssembly. When we can get to the first instruction in under a millisecond,
sometimes in the microsecond level,
then we can build applications that scale all the way to 0 when no traffic is coming in and scale up to tens of thousands when the traffic peaks. And that, to us, solves a major problem.
A common question I've seen from people that are looking at or considering WebAssembly and WASI is one of FUD, fear, uncertainty, and doubt. In your opinion, is WebAssembly and WASI ready for production server-side applications?
Now, I think that kind of question ends up being sort of a loaded question because if there's one thing I've learned from technology, the day the software comes out, people will use it in production, whether you want them to or not. But actually, it leads to a very interesting approach to how we designed the systems we've designed, really going back to Crestlet and Waggy and Bindle and going forward into Spin and Fermyon Cloud. Our design philosophy has been that rather than sitting around and waiting for something to be done by whatever my definition of done is, a more interesting approach is to say, well, does it solve the problem at hand? And can I figure out a good way to solve the problem at hand with the technology as it is today? And be forward-looking enough to, adapt as the technology changes. So we wanted to build web applications in WebAssembly. Well, WebAssembly didn't have networking when we first decided we were going to do this. Did not have an HTTP client or anything, right? It just had the core WebAssembly runtime and WASI, which gave you environment variables and file system access. And we said, all right, what can we do with environment variables and file system access to build a web application style runtime? And we went, well, there was CGI, and CGI did this with file system and environment variables. Let's implement CGI style. let's implement CGI style programming in WebAssembly. So, about a year and a half ago, we built, 2 years ago, we built Waggy, which was exactly that, a CGI style runtime for WebAssembly modules that we could begin demonstrating, look, you can build stuff today using WebAssembly as it is today, and you can run it in production today. Do we recommend you run it in production? Probably not yet, because we're not totally sure what the scaling features and stuff are, but it'll work. It's solid. To my knowledge, if you took a Waggy module that we wrote 2 years ago and dropped it into Fermyon Cloud today, it would still execute, and it would execute, with the exception that I fixed a couple of environment variables because I misread the CGI spec. It will run exactly the same today as it did the first time when we released Waggy a couple of years ago. To me, what that indicates is that it was production ready, right? The stuff we could do and build and run in a live public environment then is still stable and executable today. Now, technology has advanced since then. The component model is much more mature now. We've been able to understand more and learn more about the best ways to execute WebAssembly. And so we've added on new features, and Spin can run a different style of application than just the Waggy kind that we ran before. And so in a sense then, we're seeing the technology progress, but all along we've been meeting it where it is and building things on top of it that we believed could be production-ready things. Is WebAssembly done? No. Will WebAssembly be done in a year? No. 5 years? No. 10 years? Probably not. HTML is still getting iterated on. JavaScript, CSS, and I think the same will be true for WebAssembly. There's no reason to sit around and wait. We can do with the technology what we can do today, and we can build things that are useful today and are production quality today. And then tomorrow, when a newer, shinier feature comes along, we will adapt.
So before answering that, I think I take a step back and look at two major trends that are happening and have been happening in computing for a couple of years now. And they're rapidly accelerating over the last year, but the main trends are, you have on one hand, widely used programming languages that have started or have had support for WebAssembly for a while now. And you can put Python, C#, Go, Rust, Kotlin, right? A lot of languages on that list, with more and more announcing various levels of support for WebAssembly. JavaScript, Java, even COBOL and Fortran are on the list, right? So we have more and more programming languages that are adding support for WebAssembly. And then on the other hand, at the same time with the first trend is you have WebAssembly making its way outside the browser into more and more environments. So WASI and the emerging component model are enabling scenarios like plugin models in databases and games and e-commerce platforms and service meshes and extending products with user-defined functions and that sort of thing. You have WebAssembly popping up in artificial intelligence and used for packaging machine learning pipelines and deploying them to IoT devices. It's popping up on the edge, and more platforms are adding support for WebAssembly functions. And then in cloud computing with workloads in Kubernetes and Nomad and building actors and serverless functions and the new class of microservices and a lot of really exciting and interesting use cases that are popping up every week. So I'd look at those two and really look at if you put them together and try to imagine how that ecosystem will look in, say, 6 months or 12 months, I could see it having a really, really big future in the computing industry.
When you flip that around, what are some of the challenges and what have you learned about running WebAssembly in a production environment?
We have learned that WebAssembly is actually shockingly easy to run in a production environment. And it helps because we're all coming from heavy Kubernetes backgrounds. We've been around the block before. We know how these systems have to function. We've seen behind the curtain in Azure and some of us in Google as well, and we know what it takes to operate these kinds of platforms. But WebAssembly provides all the security boundaries and the process management and all of that as part of the execution context. So we have had a much easier time of building a system that can execute WebAssembly in production than if we had, say, tried to build it. The Kubernetes Docker story was a very hard one that was fraught. Lots of very difficult, low-level problems to solve that WebAssembly, just in virtue of the way it operates, doesn't have. We also made a major change, right? Instead of scheduling with Kubernetes, as we initially tried to do with Crestlet, we switched and used Nomad. And Nomad is built to be able to execute different kinds of workloads, not containers. You know, when I first went to the very first HashiConf, it was in Portland, Oregon, I believe, and they announced Nomad at that conference. And it stuck with me because they said, now you could run a containerized application side by side with a Java application with a hosted JVM. And I'm going, why in the world would anybody want to run a hosted JVM? That's, you know, that sounds just silly. And then years later, as we're looking at WebAssembly, I'm like, well, if they could host a JVM, you know, certainly they could host a WebAssembly runtime, which is lighter weight and, you know, more secure. And sure enough, we managed to do that again, right, you know, Crestlet was tens or hundreds of thousands of lines of code. Our first go at writing a task, being able to schedule WebAssembly tasks in Nomad was about a 15-line HCL configuration file and no code. And, you know, that continued on for years. If you go take a look at Fermyon platform, the open source version of our platform, still it's a couple of HCL files, a little bit of a helper script here and there. But for the most part, you know, maybe dozens of lines of code, not hundreds, not thousands, and certainly not tens of thousands of lines of code. And the reason why is because Nomad is really built to be able to handle and orchestrate different kinds of execution contexts, whether it's a container, a virtual machine, JVM, or now WebAssembly modules. And so we found it to just be a great fit. And because of that, and the sort of characteristics of WebAssembly in general, as we built out the platform, we've been sort of, you know, pleasantly surprised is almost understating it. It's like joyously shocked would be a better way of describing it, right? That things are just working and we're not hitting major roadblocks as we start to scale up, and we're still hitting remarkable performance numbers on very modest cloud resources, and that's really exciting.
So I start answering this by going back to the Crestlet conversation, and Crestlet was really our experiment to running WebAssembly on the server in a container orchestrator environment. So of course, us being in the Kubernetes team, around the Kubernetes team at Microsoft, we naturally tried to do that with Kubernetes. And what we found, it was fairly difficult to adapt the kubelet to run something that was not a container. So what the level of abstraction we chose there was a pod, and it just incredibly difficult to get the Kubernetes kubelet to stop making assumptions about the underlying thing that it's trying to run, about the networking infrastructure and the storage infrastructure, and assigning an IP address, which takes about a second or so, right? So there were a lot of things that the kubelet made assumptions around. And when we started Fermyon, we decided to take a step back and rethink that decision, and we looked at Nomad as the alternative to Kubernetes. And what we found, it took us a few days to go achieve the same functionality that we had in a really long time with Crestlet. So building on top of that, expanding Nomad and building on top of Nomad for new workloads, for new kinds of applications was surprisingly easy, and we've had a fantastic time expanding Nomad with task drivers to just run WebAssembly natively instead of either containers or the other task drivers that Nomad can run. And it was a very intuitive and very reliable way to run WebAssembly on the server for us.
So as of today, Fermyon Cloud enters a phase called open beta, where people can sign up and try and run in their WebAssembly workloads. What are you looking for from people as they explore Fermyon Cloud during this open beta phase?
First of all, thank you for considering to use Fermyon Cloud and for trying it out. The main thing that we're hoping to learn from the open beta phase is learning the types of workloads people want to run in the cloud in such an environment, and trying to understand what features people really want from such an environment. So please give it a try. Please give us honest and hard feedback, and would love to learn more.
finally one that I can speak authoritatively about. I am the one who named Bartholomew. It has absolutely nothing to do with particle physics. However, I have never told anyone why I named it Bartholomew. And I don't plan on telling anybody why I named it Bartholomew.
Nope. We don't talk about Bartholomew.